Hello students, welcome back. I am Rinkesh sir, and today we will continue with chapter number 4, that is principle of mathematical induction. Today we will continue with exercise 4.1. In our last video we had completed the first 4 questions. So today we'll start with question number 5. Okay, so let's start with question 5. Question number 5, 1.1 into 3 plus 2 into 3 square plus 3 into 3 square up to n into 3 raised to n. You have to prove this as 2 raised to n minus 1 into 3 raised to n plus 1 plus 3 upon 4. Okay? Okay, so first for P of 1. LHS, when I put n equal to 1, 1 into 3 raised to 1 means the first term. 1 into 3, this is equal to 3. RHS 2 into 1, that is 2. Okay, I'm writing directly. 2 into 1, 2 minus 1, 1. 3 raised to 1 plus 1, 2 plus 3 upon 4. So this is 3 square, 9 into 1, that is 9 plus 3, 12 by 4, and that is equal to 3. So LHS is equal to RHS, hence P of 1 is true. Okay, now for P of K, we have to prove, sorry, we had to assume that P of K is true. Okay, let P of K be true. So what does this imply? 1 into 3 plus 2 into 3 square plus 3 into 3 cube up to K. Instead of N, I will use K. 3 raised to K. This will be equal to 2k minus 1, 3 raised to k plus 1 plus 3 upon 4. Okay, we had assumed this as true. Now for p of k plus 1. For p of k plus 1, we have to prove, instead of n, I will use k plus 1. 1 into 3, 2 into 3 square up to k plus 1 into 3 raised to k plus 1. This is equal to, now 2 into k plus 1. So that will be equal to 2k plus 2 minus 1. So 2k plus 1. 3 raised to, now instead of n, k plus 1 plus 1. So k plus 2 plus 3 upon 4. Okay. So now let's take LHS. Now see, we were using the shortcut. Till here it will be, before this term it will be k into 3 raised to k plus 1. So this one, so I will take this 2k minus 1, 3 raised to k plus 1 plus 3 upon 4 plus, for the last term here, k plus 1, 3 raised to k plus 1. Okay, so now let's take the LCM. LCM will be 4. It will be 2k minus 1 whole raised to 3k plus 1 plus 3 plus, it will be multiplied by 4, 4 into k plus 1 whole raised to 3k plus 1. So now see here, 3k plus 1 and 3k plus 1, I can take common. Sorry, 3 raised to k plus 1. So it will be 2k minus 1 plus 4 into k plus 1. So 4 into k, 4k plus 4 into 1 plus 4 plus 3 upon 4. This will be equal to 3 raised to k plus 1. 2k plus 4k, it will be 6k. Minus 1 plus 4, that will be equal to plus 3. Plus 3 upon 4. Okay. So now let's take 3 common here. 3 raised to k plus 1. So now 3 twos are 6. So 2k plus 1 plus 3 upon 4. Now see 3 into 3 raised to k plus 1 means 3 is having power 1. So 1 plus k plus 1, 3 raised to k plus 2 into 2k plus 1. So I will write 2k plus 1 ahead, 3 raised to k plus 1 plus 3 upon 4. Now see this is equal to RHS, right? Okay, so P of 1 is true. Name this as 1, this as 2, and this as 3. So from 1, 2, and 3, according to principle of mathematical induction, P of n is true for every n belonging to n. Clear? So this was about question number 5. So just note it down. Now let's move to the next, that is question number 6. Question number 6. 1 into 2 plus 2 into 3 plus 3 into 4 up to n into n plus 1. And you have to prove this is equal to n plus 1, n plus 2 by 3. Okay. So let's take for P of 1. LSS 1 into 1 plus 1 means 1 into 2, this one. That is equal to 2. RHS 1, 1 plus 1, 2, 1 plus 2, 3 upon 3, 3, 3 gets cancelled. So it is 2. Hence, P of 1 is. Now let P of k be true. This is our second step. Okay, so what does that mean? 1 into 2 plus 2 into 3 plus 3 into 4 k into k plus 1, that is equal to k plus 1, k plus 2 upon 2. Okay, now this is number 2. Now for p of k plus 1, we have to prove 1 into 2 plus 2 into 3 plus 3 into 4 up to, instead of n, k plus 1. Instead of n plus 1, k plus 1 plus 1, that is k plus 2. We have to prove this is equal to, instead of n, k plus 1. N plus 1, k plus 1 plus 1, k plus 2. K plus 1 plus 2, k plus 3 upon 3. Okay, so now LHS. So we'll use a shortcut. Before this term, it will be k into k plus 1, means this one. So I'll use that RHS, k plus 1, k plus 2 upon 2, plus the last term, k plus 1, k plus 2. So now I can see here that k plus 1 and k plus 2 I can take common. Okay, sorry, here there is a mistake. It's yes upon 2, 3. Here also there is a mistake. We need to do it 3. Okay, so now I can take k plus 1, k plus 2 common. Okay, sorry. So here it will be k by 3 plus 1. Okay, let's take LCM. K plus 1, k plus 2. It will be k plus 3 upon 3. Right? And that is our RHS. So this is equal to RHS. Okay, let's name this as 3. So from 1, 2, and 3 according to principle of mathematical induction. P of n is true for every n belonging to n. Clear? So first we took P of 1, we proved it true. We assume P of k equal to true, and from that we proved that P of k plus 1 is true. Clear? This was question number 6. So just note it down. Now let's see the next question, that is question number 7. Question number 7, 1 into 3 plus 3 into 5 plus 5 into 7 up to 2n minus 1, 2n plus 1. We have to prove that this is equal to n into 4n square plus 6n minus 1 upon 3. Okay, so let's stick to the basics. LHS first for, sorry, not LHS, for P of 1. That is 2 into 1 minus 1, 1, 2 into 1 plus 1, 3. 1 into 3, the first term. LHS is equal to 1 into 3 equal to 3. RHS, so put value of n as 1. 4 into 1 square, 4. 6 into 1, 6. Minus 1 upon 3. Okay, so 4 plus 6, 10. 10 minus 1, 9. This is equal to 9 by 3, and that is equal to 3. So LHS is equal to RHS. Therefore, P of 1 is true. Okay, now let P of k be true. For that, we will assume that 1 into 3 plus 3 into 5 up to 2k minus 1 into 2k plus 1, that is equal to k 4k square plus 6k minus 1 by 3. So instead of n, I had put k. Let's name this as 2. Now for P of k plus 1, we have to prove 1 into 3 plus 3 into 5 up to. Now instead of n, I used to put k plus 1. So 2k plus 1 minus 1. So it will be 2k into, again 2k plus 1. Sorry, 2k plus 2. Sorry, my mistake. Here will be 2k plus 2 minus 1. 2 into k plus 1. 2k plus 2 minus 1. It will be 2k plus 1. And here 2 into k plus 1, that is 2k plus 2 plus 1, that will be 2k plus 3. That is equal to, instead of n, k plus 1, 4 into, see, I am solving it here side, 4 into k plus 1 whole square. So that will be equal to 4 into k square plus 2k plus 1. So 4k square plus 8k plus 4. Clear? Plus 6n. So plus 6 into k plus 1. So that will be equal to here plus 6k plus 6. Okay, and minus 1. So minus 1. So this, sorry, 6k. Okay, so it will be 4k square plus 8 into 6. Sorry, 8 plus 6. 14k. 6 plus 4, 10 minus 1 plus 9. Okay, so I'll solve this in rough. Instead of this, I can write down 4k square plus 14k plus 9 upon 3. Okay, so now LHS. We are using the shortcut, we'll use this k into 4k square plus 6k minus 1 upon 3 plus 2k plus 1, 2k plus 3. So this will be equal to k into, or let us multiply, k, okay, let it be k common, 4k square plus 6k minus 1 upon 3. I will take LCM, 3 into, let's multiply this, 2k into 2k, 4k square, 2k into 3k, that is 6k, plus 1 into 2k plus 2k, so plus 8k, okay, plus 3 into 1, 3. Clear? Remember this, 2k into 3k, 6k plus 2k into 1, 2k. So I have written 8k. Okay, into 3. So now let's multiply 4k cube plus 6k square minus k plus 4 3s are 12k square plus 8 3s are 24k plus 3 3s are 9 upon 3. Clear? Okay, so solving this further, I will get 4k cube plus 6k square plus 12k square. So that will be plus 18k square minus k plus 24k. So that will be equal to plus 23k plus 9 upon 3. Okay, now we need to factorize. Okay, so now we will factorize the numerator. Okay, now see here, for numerator 4 and 23, 4 plus 23 means the coefficient of odd terms, that is 27, and 18 plus 9, that is the coefficient of even term, that is also equal to 27. So both are same, right? As the coefficient of odd terms are same, that means x plus 1 is a factor. Here it's k, so k plus 1 is a factor. Okay, so how we used to factorize it? In this way. Write down the coefficient 4, 18, 23 and 9. Clear? Now k plus 1 is a factor, that means k plus 1 equal to, we will take equal to 0. So k equal to minus 1. So here I will put minus 1. So what is our step? First we will put here 0. 4 plus 0, 4. Now 4 into minus 1, minus 4. 18 minus 4, 14. 14 into minus 1, minus 14. 23 minus 14, 9. 9 into minus 1, minus 9. So that will be 0. 9 minus 9. So when we will factorize this, what we do? We do k plus 1 is a factor. K plus 1. So now what is the first? It was cube. So we'll jump to the next, that is k square. 4k square plus 14k plus 9 upon 3. So this is our answer, right? And you can see here, this is our RHS. K plus 1, 4k square plus 14k plus 9. So this is our RHS. So from 1, 2 and 3, according to principle of mathematical induction, P of n is true for every n belonging to n. Here, this was about question number 7. So just note it down. Now let's move to the next, that is question number 8. Question number 8. 1 into 2 plus 2 into 2 square plus 3 into 2 square up to n into 2 raised to n. You have to prove that this is equal to n minus 1 into 2 raised to n plus 1 plus 2. Okay. So first we will use our the same method for p of 1 LHS. So 1 into 2 raised to 1, 1 into 2. This is our first step. This is equal to 2. Okay. RHS n minus 1 means 1 minus 1, that is 0. 2 raised to 1 plus 1, 2 plus 2. Now whatever you are multiplying it by 0, it will be 0 plus 2, so it is 2. So LHS is equal to RHS, hence P of 1 is, let's name this as 1. Now second step, our second step, let P of K be, okay. So 1 into 2 plus 2 into 2 square plus 3 into 2 square up to n into 2 raised to n. This is equal to, not n, I will use k. K into 2 raised to k, that is equal to k minus 1, 2 raised to k plus 1 plus 2. Okay, let's name this as, now for p of k plus 1, we have to prove 1 into 2 plus 2 into 2 square up to, instead of n, I will use k plus 1. Instead of 2 raised to n, 2 raised to k plus 1. That is equal to n, k plus 1 minus 1. So it's k. 2 raised to k plus 1 plus 1. So it will be 2 raised to k plus 2 plus 2. Okay. Now let's take LHS. For that, we will use the shortcut. Before this term, it will be k into 2 raised to k. So this, that's it. This equation 2, I will write down k minus 1 into 2 raised to k plus 1 plus 2 plus the last term of this, k plus 1 into 2 raised to k plus 1. Clear? So now see here, 2 raised to k plus 1 and 2 raised to k plus 1. It's common here. So I will take 2 raised to k plus 1 common. It's k minus 1 plus k plus 1. Okay, plus 2. Clear? So this will be equal to 2 raised to k plus 1 into minus 1 plus 1 get cancelled. It's 2k plus 2. Carrying it forward here, 2, I will write down k. Okay, 2 means 2 raised to 1. 2 raised to k plus 1 plus 2. So now k into 2 raised to 1. Here the base is same. So 1 plus k plus 1, that will be equal to k plus 2 plus 2. Here, and this is equal to RHS. So let's name this as 3. We have proved P of 1 is true. We had assumed P of k equal to true, and that proved that P of k plus 1 is true. So from 1 to And 3, according to principle of mathematical induction, P of n is true for every n belonging to n. Clear? So this was about question number A. So just note it down. Okay, students. So that's it for today. In our next video lecture, we will continue from question number 9. Thank you.